Right, it's just coming up to 2 p.m, so I think we'll make a start. Good afternoon, everyone, and thank you for joining us to this webinar on behalf of the whole OpenLV project team. My name's David Russell, and I'm the EA Technology Project Manager for this project. This is the first two sessions where we'll be talking about the learning amassed by the project and what it's achieved over its 3.5-year lifespan. In the first session, we'll be concentrating on the technical and network elements of the project, the distributed intelligence technology that we trialed and what we achieved when we put it onto low voltage substations. Would it be able to live up to the expectations and monitor the network, perform calculations, send alerts, and actually perform control functions? The second webinar that we'll be holding on Thursday of next week will cover the successful community and commercial elements of the project. We pose questions like, was there an appetite amongst these organisations to actually receive network data? And if so, what would they do with it? If you haven't had a chance to enrol for next week's webinar, then you can do so via the link on the front page of the project website, which is www.openlv.net. You'll also find lots more information about the project on that website, including lots of in-depth information that we just won't have time to cover in these two sessions. So first, a quick overview of the OpenLV project. OpenLV is a 3.5-year project with a £5.5 million budget. It's funded through Ofgem's Network Innovation Competition, which is held annually, and where back in 2016, Western Power Distribution bid to demonstrate new technologies that could benefit their customers. It's been delivered by project partners Western Power Distribution and EA Technology. But I must say we've received valuable support from Lucy Gridkey, Nortec, NCC Group, the Centre for Sustainable Energy, and Regen. And you'll hear from some of these organisations today and others next week. EA Technology were responsible for the day-to-day management and oversight of the OpenLV project, which deployed trial equipment in 80 Western Power Distribution substations. We're also the primary developer of the Lvcat technology that the project trialled. The trials that we will describe this afternoon were hosted on Western Power Distribution's low voltage network across the Midlands, South West England and Wales. I'll now pass over to Sam Rossi Ashton of Western Power Distribution, who'll tell you a little more about why, back in 2016, WPD backed this project and what they actually wanted to learn from it.
Good afternoon, everyone. The OpenLV project is built on learning generated from many of our previous innovation projects. Projects such as Smart Hooky, Community Energy Action, and Solar Bristol shows that there was an appetite among community organisations to receive and use substation data. This project has allowed us to explore their enthusiasm and to investigate how people from outside of the electricity industry would use LV network data if it were to be available locally. The team will tell you more about this part of the project next week. Of course, the distributed intelligence platform must be able to provide benefits to us, the network operator. So part of OpenLV was about demonstrating how it could provide WPD with a technology that would give us greater visibility about activity on our network, about the health of our assets, and the ability to plan for an increasingly complex future. We also wanted to understand its ability to underpin the path that takes us from being simply a network operator to being a system operator. This was achieved by pinpointing problems with a particular assets, being able to send signals to loads of low carbon technologies connected to our network, or even autonomously control the network itself. It is, of course, vital that this is done without compromising the safety and security of our network, so we needed to be assured that the cybersecurity had been considered and that our network and any other network adopting similar technologies is protected in the future. Importantly, we think about the cost of this, so we had a look at whether the platform actually delivers value for money to the bill payer. Today's webinar will focus on the benefits that technology can provide to the network operator.
Thanks, Sam. So in this session today, what we'll cover is, firstly, an overview of the Lvcat technology, which was central to the project. Then a summary of the work undertaken by independent cybersecurity experts, NCC Group. Thirdly, we will describe the trial that the project team undertook on Western Power's low voltage distribution network. We'll then provide a brief overview of the findings from this element of the project. We will then provide a very brief insight into next week's webinar, including mentioning some of the companies who worked with us to create apps that would be of direct benefit to a DNO, either through interoperability or providing useful services to them. We'll then provide a quick description of some of these exciting benefits before finally answering as many of your questions that we can in the remaining time available. So, as I just mentioned, we will be hosting a question and answer session at the end of the webinar, where we'll be joined by colleagues from Western Power Distribution and NCC. So can I ask you to please feel free to submit your questions as we go along using the question bar, I think, on the right of your screen. If you can use that and send through the questions, we'll collate them and I'll pose them to the panel, or as many as we can. But don't worry if we don't get to your question, because we'll be posting all of the questions and the answers on the project website. So rest assured you will get an answer. So, what is Lvcat? Lvcat stands for Low Voltage Common Application Platform, and it provides a low-cost, robust substation monitoring and management system. It's a distributed intelligence technology that allows calculations and decisions to be made within the substation rather than requiring central intervention, and importantly, it doesn't need reliable data communications. So manufacturers, developers, and academics can develop apps using raw substation data in a similar manner to Google Android and iOS. You can think of Lvcat as being an operating system for the substation. And it securely hosts these apps while allowing seamless transfer of data across its systems and to external parties. Lvcat was initially developed as part of an Innovate UK project, and it was a collaboration between EA Technology, Nortec, and the University of Manchester. The platform has been further refined by the team at EA Technology into the pre-production technology that we deployed in the trial. So in a bit more detail, what can the technology that we trial actually do? Well, firstly, it can monitor the transformers and the cables found in a distribution substation. It can measure a full range of parameters, including voltage and current and local environmental conditions, such as temperature. And these are necessary to determine asset condition and performance. The measurements were typically taken at 10-second intervals at every substation in the trial, but that can be varied to suit site-specific conditions, so it doesn't have to be every 10 seconds. Then the platform can record these measurements for use in a number of ways according to the needs of a particular situation or operator. For example, they can be simply transmitted to a central aggregating server, say once a month, and in the trial that's what we did, but again you can set other timescales if you need to. Or the measurement data can be used to perform calculations locally, actually on the platform, with only the key information being uploaded to the central database, and doing that either periodically or when specific alert thresholds are met. Key is that the data can be used by multiple apps hosted on the platform, and the results of the calculations from one app can actually be shared with others. Only the results of these calculations then need to be sent to the central server rather than transmitting all the data in full. The app outputs might be used by a network operator to predict future network conditions or to estimate asset health based on the data it receives. Community groups or housing associations may want to use the data to help explain energy issues to local residents in a very accessible way, using information that has a meaningful relevance to them. Or the data could be used to set up real-time exception reporting. So, for instance, if the temperature of a monitored transformer or the load in a particular substation was about to exceed a predetermined limit, then a signal could be sent to a central server within minutes, allowing speedy, centrally managed interventions if needed. And perhaps most excitingly, the data could be used by the platform to actually enact decisions locally. Based on the data it receives and the calculations it performs and predetermined thresholds, the Lvcat platform can actually influence or control the LV network in real time. For example, Lvcat could issue control signals to loads such as electric vehicles, electrical appliances, or low carbon technologies such as distributed generation or battery storage. Alternatively, it could directly reconfigure the network to move or share load between transformers. And that's something we've demonstrated within the project and which we'll hear more of soon. As part of the OpenLV, we tested many of these scenarios. So what are the advantages of using Lvcat technology? Well, for a start, it can cut down on mobile data costs because the platform only needs to report exceptions. It doesn't need to send large chunks of data on a daily or weekly basis, even every time a data point is gathered. It only needs to send a small message on occasion. It can also reduce the amount of equipment needed in a substation. So rather than having lots of different, potentially quite bulky items doing a variety of tasks, apps can simply be created and hosted on the platform to perform many different roles. A single set of measurements can be shared between all these apps. And this reduces costs and also potentially avoids situations where some measures can't be deployed simply because there's limited space in some substations. It can also prevent vendor tie-in. So anyone can create an app to be hosted on the platform. And as the commercial element of the trial proved, there actually is an appetite to develop apps that may be useful to network operators. It can help automate tasks that at the moment are completed manually, making them less time consuming and producing more accurate results. As part of the project, Nortec created an app that automatically gathers maximum demand indication data at each substation. The current manual method is that a single data point from each substation is gathered annually, requiring a substation visit. This app avoids the need for a substation visit and allows the data to be gathered much more frequently if necessary, and also reduces the likelihood of any transcribing errors on site. Exception reporting can also be really useful. It can help flag up assets that may be struggling or networks that might need attention, allowing the prioritization of investigation rather than requiring routine interrogation of data from thousands of different substations. And the local decision making at a low voltage level can allow action to be taken quickly, minimizing the input required from control level staff. This allows them to prioritize their attention to issues that may arise at higher voltage level, where their expertise and input can have a greater impact. Of course, it was very important to us and to WPD to ensure that this distributed intelligent technology, such as Lvcat, in no way compromised the security of their network. To ensure that the platform was as secure as possible, and to reassure WPD, we brought in experts from an external cybersecurity organisation. And I'll now pass on to Aaron from the NCC group, who will explain the work that they undertook.
The objective of NCC Group assessment was to define the baseline and enhance security control standards that are required and expected to be in place for the business as usual deployment of the distributed intelligence platforms. In addition, it also provides the security controls that are needed to ensure secure development and connectivity from DNOs and other third parties. These security standards require all future devices to have advanced security controls due to the potential risk impact of all use cases on this type of platform. As a deliverable of this project, we have produced a set of technical security standards that provide a list of recommendations to DNOs and other network operators suggesting guidance that they should consider if or when they deploy distributed intelligence platforms for all use cases. However, to summarize, all operational tiers of intelligence substation devices possessing the same threat and risk from a cybersecurity perspective implement baseline security controls as a minimum to ensure secure operation and management of the platform. Consider the implementation of enhanced security controls, as this will add additional layer of security to baseline controls, and continuously monitor the cybersecurity threat landscape and determine its impact on the platform. As the Lvcat solution is aimed to monitor substation performance and electricity demand across regions within the United Kingdom and integrate with third-party products and applications, the security of the platform and the data generated, processed, and transmitted are of paramount value and importance. In consideration of both the baseline and enhanced security controls of the Lvcat solution, we assess the business context, risk, impact, likely threats from the external and internal threat actors to the distributed intelligence environment, from cryptography, access control and authentication, endpoint security, hosting and cloud, logging and monitoring. I will now pass to WPD, who will summarize the work they undertook. Thank you.
Decarbonisation, the shift to increasing renewable generation with low carbon loads, is radically changing the way that we manage and operate our network. For a long while now, we've been connecting renewable generation from sources such as PV or wind, and doing this at all voltage levels. A more recent trend has seen us connecting higher volumes of new low carbon loads such as EVs and some heat pumps. In addition, we're also starting to see the connection of battery energy storage, either as standalone systems or as EVs with the capability to transfer energy back to the grid. These changes are increasing the overall amount of power that's transferred around our network, and it's fundamentally moving away from the traditional top-down model of power flow that has existed for decades and for which much of our network was designed and built. We're increasingly seeing now what is dynamically changing mixes of top-down, bottom-up, and transfers of power within voltage levels. More and more, we're wanting our network to be able to flex to accommodate these changes and dynamically changing use cases. To achieve this radical change in the operation of the electricity network, it's necessary that we understand in more detail the power transfers that the network is facilitating. We also need to understand the extent to which these transfers are approaching the physical limits of the network, so that we could dynamically reshape the network or manage the transfers that are occurring. New technologies are required to achieve this. So these changes require us to monitor the operation of our network more closely and more widely, and then to assess the status, capability, and operational options for specific portions of the network. This data and the assessments that flow from it allow us to do two key things. To optimize the use of the present infrastructure, including autonomous control of specific sections of network, and to plan for the future and prioritize our investment. The new distributed intelligence platforms, such as Lvcat, have the potential to support these requirements. This trial was all about demonstrating and proving that the product could live up to all of our expectations before we considered rolling it out to business as usual. The Loadsense network trial aimed to demonstrate the capability of the Lvcat platform by setting up sites to either mimic or actually undertake automated load sharing. Pairs of connected substations were identified where automated load sharing could reasonably take place. To achieve this, both substations in the pair were fitted with an Lvcat platform. This equipment then monitored the substation, assessed the capability of the transformer to supply the load, and then optimized the supply arrangement. During periods of low demand, the selected load was supplied by just one substation. During periods of high demand, the load was supplied by both substations. The trial was conducted with two groups of substations. In Group 1, 25 pairs of substations were identified. The equipment was installed in each substation for all pairs. The equipment was commissioned to monitor, assess, and mimic optimization of supply. In Group 2, 5 pairs of substations were identified, and Alvin reclose units, acting as LV control elements, were also installed and commissioned to be able to switch the network state. So at these 5 sites, the scheme not only monitored, assessed, and identified the optimized state, it was also able to autonomously switch the network. During periods of high demand, which were determined by the transformer temperature, an Alvin reclose unit was commanded to close, and the selected loads were supplied from 2 substations at the same time. This sharing of the load between the substations reduced the more heavily loaded transformer temperature. The substations included in the trial were chosen to comply with a fairly lengthy list of requirements. This included having sufficient installation space, to be operating at 50% or more of the transformer rating, to have good mobile data signal strength, and finally, to create an overall set of substations that was representative of the broad range of substations and loads that WPD serves. To identify the 30 pairs of substations for the trial, EA Technology conducted desktop surveys of 149,000 sites, and 400 substations were visited to arrive at the final set. So once appropriate substation pairs for this trial were located and the equipment was installed and commissioned, a significant volume of operating data was built from the 25 pairs making up Group 1. And real and successful operating experience was accumulated from the 5 pairs in Group 2 that actually controlled a specific portion of network.
Thanks, Chris. The OpenLV project gathered, as you might have already heard, gathered huge quantities of network data over its lifetime. Each day, approximately 15 million data points were captured across the 80 substations that we were monitoring. That equates to around 10,000 data points a minute, or a staggering 5.5 billion data points every year. And when you think across the UK, there are roughly 230,000 ground-mounted distribution substations and another 350,000 pole-mounted substations. That's nearly 600,000 in total. And while few will debate the need for greater visibility and control of the LV distribution network in order to help the UK achieve its net zero targets, I guess these huge numbers explain the vast quantities of data that would be involved in this undertaking. And the OpenLV project has shown that distributed intelligence can help mitigate this data issue. By local processing, it can reduce the costs involved with transmitting data by reducing the amount of data that needs transmitting. Using exception reporting to direct central controllers to issues at particular substations as they occur, and implementing local control of the distribution network, it can enable staff to prioritize actions and focus at the higher voltage levels. As we mentioned earlier, the Lvcat platform can also promote interoperability, reducing the need for multiple pieces of hardware in a substation. And this will allow a DNO to effectively pick and choose which supplier to use for different functions. We'll hear more about some of the other innovations trialled by the businesses and universities who volunteered to participate in the project next week. But here are a few that had a direct application to a network operator. As mentioned earlier, project supplier Nortec developed a maximum demand indicator that would allow the DNO to gather this vital piece of information without having to visit each substation. And project supplier Lucy GridKey provided their GridKey hardware and software to the project and a communication app that acted as an alternative monitoring platform. HASIS volunteered to provide alternative measurement devices and software protocol that was really useful to us because it allowed us to demonstrate that the Lvcat platform can operate with different LV monitoring systems. And finally, commercial participant AuxaGrid developed a voltage limits app that attempted to forecast potential voltage violations up to 24 hours ahead. Now I think we'll hear from one of these companies. We'll hear from Joe Hayden of HASIS before Sam from WPD summarises our findings.
We've been able to offer some of our equipment, in particular the feeder net system. What we've tried to do is take an existing product and could we interface that with the OpenLV platform, the Lvcat. We were pleased that that was a lot easier than we thought it was going to be. That allowed us to provide an alternative hardware to what was currently being used by the Lvcat. So to have a holistic system where everything talks to each other has got to be a good benefit.
Today's webinar has had a very narrow focus. We've examined the benefits of distributed intelligence platforms such as Lvcat can offer network operators. The network trial proved that Lvcat could provide a range of functions from monitoring low voltage network loading, performing calculations, sending alerts, making decisions and actually controlling assets. The trial proved that distributed intelligence was effective for autonomous network control. While we can state unequivocally that the technology worked, under current conditions, it would not be cost effective to deploy the technology in isolation just for network control, and it would only be required on a minority of networks. The financial case improves when the platform is used in combination with other technologies such as storage. This project also proved that distributed intelligence platforms can provide many other wider benefits to DNOs, communities and wider society. When benefits are combined, the cost benefits analysis changes. The outputs provided by NCC ensured that we did this in a manner that protects the safety and security of the network from cyber threats. But beyond that, their work provides guidelines for other distributed intelligence platforms to implement and follow. OpenLV project learning has fed directly into the Energy Data Task Force, ensuring that they are appraised of the capabilities and advantages of distributed intelligence. But Paul Breck from project supplier Lucy GridKey really sums up what could be the legacy of distributed intelligence as an enabling technology in the following clip.
And all this is about reducing the investment that we will need to make in the electricity network as things like electric vehicles and heating systems and so on come into people's houses. Future services, it's almost limitless. I think it's a huge range of things that we can do in the future with this data.
Communities have really valued being part of the trial. I think, you know, there's some of the organisations are quite small, but their ambitions are quite big, and they sort of look at local energy in a holistic manner. So they want this data basically to understand more about what's going on in their local area. The core mission of a lot of communities is to sort of engage local people in energy issues. So the OpenLV data has been really valuable in that sense because it's given the community something tangible to show to local people and say, this is what's going on in your area.
Next week, in the second and final webinar of this series, we will look at the benefits that distributed intelligence can provide to society beyond the DNO. We'll look at whether community organisations, businesses and universities are interested in network data, While we find this intriguing, are we in the minority? And if these third parties receive network data, what benefits can it unlock? If you haven't already enrolled, you can find a link to next week's webinar on the project website, www.openlv.net. You can also find the technical project report, more clips from participants, and summary leaflets there. I hope you found this interesting, and we'll now answer questions as we have time for. First, whilst we are sorting your questions, we thought you'd find it interesting to see the animation that we've created as part of the project.
The way we use electricity is changing. We own more domestic appliances and devices such as smartphones and tablets than ever before. Many of us have installed low-carbon technologies like solar panels and are switching to electric vehicles. In the future, we're also increasingly likely to use electricity for heating. All of these choices have impacts for local electricity networks. To meet increased demand for electricity and to support low-carbon generation, we need to work smarter. And to do that, we need more data. Data gives us a better understanding of our electricity use and helps to manage the network more efficiently. The OpenLV project opened up data in electricity substations for the first time by trialling an open software platform. This monitored performance and electricity demand, performed locally managed network control, and hosted apps that could benefit everyone. The project gathered around 15 million data points every day from 80 substations across our regions in the Midlands, South West England and South Wales. Volunteer community organisations, businesses and universities developed apps or were given access to data which was used in a variety of ways. Volunteer organisations used it to educate school children, increase understanding about energy use among communities, control EVs, and investigate ways of connecting more renewables to the electricity network. Since the project ended, community organisations have continued to use the network data and the web app developed for them to advance their zero-carbon ambitions and help their communities use energy more efficiently. A guidebook has also been developed to help other community groups learn from their experiences. Network operators are expanding their use of data to improve their understanding of their networks and make informed investment decisions. Work is also underway to develop a commercial platform that will enable businesses and universities to develop apps and access data, allowing innovative solutions to be developed for the wider industry. OpenLV has opened the door to a future where software platforms can be used by network operators to make data available to businesses, community organizations and others. This data will help to connect more decentralized renewable generation, and where electricity is being produced locally will enable signals to be sent to charge EVs and heat homes, helping to cut costs for consumers and benefit the environment. The OpenLV project has played an important part in moving the UK closer to a smart grid, helping to minimise network upgrade costs and paving the way for a future in which everyone can benefit from our journey to net zero.
Well, I really hope that you've found this presentation interesting and informative, and we'll start now and move on to the panel session. Perhaps an opening question: is there a need for real-time low-voltage data? Who's going to take that one? Have we got John Berry? Is he on?
Can you hear me?
Yes, we can, John.
Yeah, so for me, definitely, you know, there's much need for real-time data fully across our network. So yeah, as a digitalization manager at WPD, I'm hugely keen to increase the level of visibility we give across across the network, and I think we can drive real value from the wider network from providing real-time data to customers, stakeholders and third parties, and obviously those same groups of people can hopefully drive real benefit as we've seen from the OpenLV project to date. So yeah, we've started sharing some network data in real time, and getting down to sharing at LV level is definitely the panacea from us. And yeah, hopefully the value of OpenLV, we can keep translating that into more building solutions.
That's great, John. Thank you for that. I mean, I've got loads of questions, and I apologise for the order in which they come out. I'm just trying to collate them. But there might be another one for you, actually, John, while you're on and you're still unmuted. Question is, works on an innovation project, but what next?
Yeah, so I think that's a really interesting one. I think there's different use cases. I'm sure have been discussed earlier in the session to help, you know, monitoring data to understand where there are network pinch points, so we can understand the volumes of LCTs currently on and distributed generation or small scale embedded generation on the network, and we can understand the propensity of that going forwards, and really using OpenLV as a solution to monitor where we think likely pinch points are going to happen. That can both inform how we invest in the network, and also how we invest in flexibility solutions and solutions that work collaboratively with individuals and communities to drive the best for end users and for the network. So I think that's what we need to look at, is continuing our LV monitoring activity to understand how we can best implement it across the network. I don't think it's about monitoring absolutely every part of the LV network and providing visibility in the first instance. I think there's going to be the specific users and user sets that are looking for that data and where we can take value out of it. And I think it's about coming up with a targeted mechanism, leveraging the learning that we've got from OpenLV to continue to doing that and sharing the data with all where is available, I think.
No, that's great. Yeah, I think a lot of people would sign up for that and agree. Next question. Let me look at one list. I think this might be one for Dave Roberts. How does Lvcat fit into the work of the Energy Data Task Force and the need for open data?
Great question, Dave. Hopefully everyone can hear me.
For it, Dave. I'm just reading them out. The participants find some really good questions in.
Okay, so the OpenLV project started before the Energy Data Task Force began. But it's fair to say, and we'll hear a lot more about this next week, I think some of the use cases we've seen around the use of open data and how communities in particular have taken that data and used it have been quite fascinating. Certainly things that we didn't envisage when we embarked on this journey nearly 4 years ago. So there's some really fascinating things that have come out from there, but it's really brought to life how there's a need for data and how that data can actually be used in the communities that the network operators serve. So definitely we've seen that. We are very much seeing at the moment more monitoring being a necessity as we transition towards net zero. So if we're going to start to connect electric vehicles, and clearly talk about potentially tightening the targets as to when EVs will start to come in at that scale, or the way we heat our homes, or the way we fuel the future. We're definitely seeing a trend here that is putting the low voltage network under a bit more pressure, and so monitoring it becomes really important to understand how you can use that capacity as best you can. And I think this is very much a strategy that we've seen now in many different network operators, not just in the UK but beyond, where there's a real need to get more visibility here. So yeah, we think it's very much on par with the remit of the Energy Data Task Force, and certainly the sharing of data. And again, we see that Western Power have been releasing data, and even yesterday there was information being released for some of the real-time systems, the data that's being shared. So we can see there's an appetite for data being shared as well.
Well, that's fantastic. That's really good to know. And I know we mentioned WPD. Are other DNOs already active in this space as well?
So yes, we're certainly starting to see a number of different network operators increasing the amount of monitoring they're doing. We mentioned before, and I think you mentioned about Lvcat. We've now taken that into our production equipment, which is now being provided at scale to a number of different distribution companies. So yes, very much start of the journey, but certainly not the end. There's going to be a lot more monitoring over the next 5 years plus.
That's great. Sounds like really exciting times. Now I've got a really good question now, and it's definitely one for Aaron. Should we worry about the risk posed to our electricity network by this technology?
Yeah, thanks, Dave. Yeah, absolutely, very good question. In terms of from a risk management perspective, we still follow the standard process, because bringing in a new service like this would definitely open up new vistas in terms of new surfaces, attack surfaces, and new actors. So when we did this whole assessment, so we did take this into consideration, both from the threat and the potential likelihood it converting into risk. So the approach was to largely look in terms of secure by design and the more defensive kind of approach. So we have created something like a more minimum baseline and an enhanced baseline based on the risk-based. So it's largely driven based on the data attributes, the services. So potentially, yes, it can bring in new kind of approach towards the risk management. But in no way it's any different than how we approach risk. So that's why in the larger cybersecurity terminology today, we are working in a kind of zero trust model. So it's kind of prevention and protection can no longer give you that assurance. So that's why we were trying to look more and more in terms of how we could detect and respond. Eventually, we could recover in terms of this stuff. So it's with the new services, and we also need to enhance and have this continuous monitoring and the improvement program for the risk management.
And I guess, Aaron, that because we're trialing different types of functionality, monitoring on its own perhaps it presents less of a risk. But I guess when we get into control of the network, does that change things somewhat?
Largely, it's from looking from the specific data attributes. This is more in terms of services rather than data privacy kind of risk. So definitely, service continuity could be a major issue, but we're also looking at a pretty tightly net controlled and monitored network. So we can never, as I said, discount in terms of the risk, but having a sound risk management and a continuous risk assessment and assessment during every major changes can potentially bring down this whole element. So that's exactly for any standard risk management we would recommend.
Okay, thank you very much for that, Aaron. And I know that a lot of information is on our website in some of the reports and going in a lot more detail about the cybersecurity threats that we looked at and the mitigation measures that we can put in place, and a lot of information on the kind of going forward business as usual for that. So well worth taking a visit to OpenLV website and digging that out. I've now got quite a technical question, and I think this is probably one for Chris. What's the impact of LV switching on fault levels? Is it an issue? I don't know whether Chris has unmuted his microphone.
Yeah, can you hear me, Dave?
I can hear you perfectly. Thanks, Chris.
Excellent. Okay, so what's the impact of fault level on LV switching? Yes, because what you're effectively doing is increasing the supply capacity into a section of LV network. And so this was something that we recognized clearly at the outset. And before we carried out this trial on any of the 5 that were in the end selected, we carried out detailed fault level assessments and also carried out protection assessments to ensure that during the periods where we didn't have 2 substations supplying, but we had a slightly abnormal supply arrangement in place, that we ensured that we had sufficient capacity to be able to drive sufficiently high fault currents to drive protection. So yeah, it was something that was carefully thought about, and it did limit our choice. So the reality of being able to roll this out universally is a bit limited for that consideration. So yeah, it's a very live consideration.
Okay, thanks for that, Chris. Another really relevant one. Will the video and the slides be made available? Simple answer, yes, they will. We'll put them up on the website, and you'll be able to get slides, you'll be able to get the videos, you'll be able to get the animation. It'll all be made available for this webinar and the subsequent one next Thursday as well. So all that will be made available. Next question, let's have a look. I think this might be one for Tim. How useful can distributed intelligence be if it's not necessarily cost effective for automated network control?
Hi, can you hear me?
We can hear you, Tim. Yeah.
Check. That's good. Okay. So it's worth remembering that the purpose of the OpenLV project was to demonstrate whether the distributed intelligence in itself could provide benefits out on the network. So not just all the data that we've already checked and already covered on the conversation, but to actually make that automation more useful out on the network itself. So where we found that the actual trials and the technology approach that we didn't prove to be that cost effective in and of itself, it's more the fact that it wouldn't be cost effective if deployed widely across the entirety of the network. There are some very specific areas within the network, given network arrangements and depending on what the load profiles are, where it would be cost effective, but you wouldn't want to just roll it out everywhere. But what's more important about what we demonstrated is that the automation control and the intelligence behind it isn't limited to just network automation. It could be used for controlling anything which is connected to the network. So a battery storage system is a perfect example. It's only limited by whether the hardware that you want to connect it to is controllable. It's not limited to just being network controlled in and of itself.
Okay, yeah, I think, and there was a question about when is it cost effective?
So in terms of, if we're talking about specifically the way we did the trials ourselves in terms of the network switching and sharing load between the transformers, some of the ideal use cases for that would be where you have two different types of networks which are directly adjacent to each other within the overall low voltage network. So a good example would be if you have one transformer which is predominantly a domestic load, where you're going to have your normal evening peaks and fairly low load relatively during the day, and adjacent to it within the network and so able to be connected to it would be, say, a commercial site or maybe a small industry area. So at those times, the two different transformers have peaks at different times of the day, and hence if you've got the automation when required, you can flip and connect to those two networks together and share load between those two transformers. As I said, that's a fairly specific use case, but it's things like that in those sort of circumstances where the sort of the actual trial and the way we were running the OpenLV trials to demonstrate the technology as a whole, you could just apply that specifically into that circumstance.
Okay, yeah, I think that's a good point. Well made. Now we've got a really powerful question. I think this is probably one for WPD, not EA Technology or NCC Group, and it is that this technology is crucial for the rollout of low carbon technologies. Shouldn't we be doing this urgently and getting all done over the next decade as part of Rio ED2 and going to Ofgem and asking for the money to do it? I think that might be a John or a Sam question. John, do you want to take that one?
Yeah, I can perhaps start. Maybe Sam will have something to fill in that I've missed. So yeah, you know, I think as I'd mentioned earlier, what's really key for us is to make data work hard for us. Data in terms of understanding the level of LCTs and DG that we have on the network, and really understand what our prioritization areas are aligned with our distribution future energy scenarios that go down to a pretty regional level now to understand what volumes are. And I think as Tim was talking about the cost benefit analysis of these solutions, it's really the balance to make sure we are implementing these solutions where they are either needed immediately or there's a high probability that they're going to be needed going forwards, and certainly to make sure that that without it, the area of network is a barrier to being able to move towards net zero by 2050, and I think that's what we're working very hard internally is, and probably useful to look at our sensors and monitoring strategy, which fleshes this out in a little bit more detail, but making sure that the right information is available at the right time on the right part of the network for what's likely to happen going forwards. And we're also interested in getting as many views as possible from local authorities and local communities down to individual level of where those priorities are likely to be and why they're likely to be a priority. And then that does go into development now and funding into ED2 and understanding how we create and facilitate a network that's going to be net zero ready for when people need it.
No, that's great, John. There's a follow-up question. It's only just come in. It's really relevant to this. It's a tricky one. And what kind of level of investment is going to be needed to do that?
Well, I assume this is where Sam comes in for the planned implementation costs of rolling out OpenLV and such. But I think, yeah, perhaps there's a little bit on that from the project. But I think wider, there's, yeah, I wouldn't have any specific values of what it's going to cost and what it's going to look like. Our first ED2 plan will come out in the next year when we'll start projecting some of this more granularly. I think it's about making sure the money in is value out. I think that's always the case. I think some DNOs are looking at a wide scale, mass implementation, before need and before requirement. And I think there's a real balance to making sure that we don't not do it and limit the capability and capacity of the network, whilst not doing it too early. And I think, yeah, there's always a drive for cost, but I think it's a wider thing of stacking benefits for this. There's benefits to the socialized customer, there's benefits to specific customers, and how we stack those benefits, essentially a little bit like investing in a flexibility service. How do we invest in this and drive real value out for customers?
Well, I think you're right. I think it's not just a case of investing for investing's sake. It's driving that benefit out and being able to identify that stack of benefits, because technology like this delivers single benefits. It delivers such a range of them, and being able to make sure that you match the investment in the technology to the benefits you're trying to drive out is absolutely key. Don't know whether anyone else has got any views on that. Anyone else from the panel? I was thinking whether Dave has got any views more widely on how we see that going forward.
Yeah, certainly. Just picking up on a couple of points. I mean, we've seen just in the course of the project, we've seen many more parties now from the supply chain offering monitoring solutions. We've seen the price of monitoring drop quite considerably, and we're starting to see that continue. So, I mean, back to one of the points we talked about before, there's over 250,000 ground-mounted secondary substations in Great Britain. So if you think about monitoring every single one of those over the next decade or so, it's a significant challenge. And one of the things that we do see is having something that is relatively low cost that can provide that benefit stack is pretty key. And that's one of the things that we thought about when we designed Lvcat, because it allows you to use the same piece of hardware, but to change the functionality of that hardware basically over the air as you drop different software applications onto it. So it provides that sort of future proofing, if you like, in a context of a piece of hardware, but ultimately that hardware needs to be pretty standard, because you don't want to be creating things that are specific to just one part of the country or one part of the world, in fact. So, economies of scale are only achieved from us as a supply chain if you have standardization, because that really starts to drive that through.
Okay, thanks for that, Dave. Another question come in. Is there a catalogue of apps that have been developed? And that's a really useful one, because it allows me to kind of advertise the new project brochure that we're just releasing today and will be available on the website for download, which really does detail that and details the case studies from the network apps, the community apps, the industrial apps, even the academic work that's been done. So if you want to go to the website and download that, you'll find all that information and probably much more in a very useful, compact brochure. Another question from a participant: will the raw data be available after the project finishes? I think that might be a kind of one going your way, Sam.
Yes, absolutely. So yeah, we have an activity remaining on the project that's archiving this data and standardizing it to some extent. We have a project that's running parallel to this called Presumed Open Data, and what that project has done has created a methodology to understand and mitigate any risks that are posed by sharing large data sets. And so we've actually I've run this data set through that methodology, and pleased to say that it's kind of green lighted for wider sharing, and so it will be available in due course. So we appreciate that it's one of our largest data sets from an innovation project, and we're very keen for people to perform additional learning on it after the end of the project. So yes, it will be available in due course.
Thanks, Sam. Another really interesting question, quite a techie one, might be one for either Chris or Tim. This. What happens if the comms fail during controlling the network?
I can take that one.
Tim?
Well, in the trial, the way we had it set up initially, then what was intended there would be the system would default back to safe operating state. So it would essentially open up the breakers and revert back to not doing any active control on the network. Now, the reason for that was because, firstly, we'd been very careful to ensure that the sites that we did install, it didn't need the system to be operating to keep the network in a safe state. That was a really clear and upfront requirement for when we were selecting the sites. So it was preferable, given that we were trialing the software and trialing the system, to make sure that it wasn't doing anything that we wouldn't want it to do if we couldn't access the unit to be able to turn it off. Now, moving forward into a sort of business as usual situation, then at that point, the intention would really be that ideally you're not going to be having to do regular and frequent checks on the system anyway. You're putting it out because the control system has been rated and has been approved for autonomous operation. So you would then be working on the fact that actually you're trusting it to do what it needs to do, and it will just report back afterwards once it does have comms again to say, this is what I've been doing, I've opened and closed over this period. That was our intention working into it. If you want to add anything else onto that, Chris.
I don't think so, Tim, enormously, other than to say, yeah, that particular use case of comms becoming unavailable was clearly looked into, and so there was this fail-safe mechanism built in.
Okay, thanks, Tim, and thanks, Chris. I'm acutely aware of the time, and I've probably got time for one more question. And I'm probably going to push that WPDs where let them have the kind of last say on this session. There's quite an open question there. I don't know, Sam or John, what is WPD doing next? I'm not sure whether that's in the innovation space in terms of low voltage or rollout of this. Quite an open question, but I'll let that be the last question. I don't know whether Sam or John wants to take that one.
Yeah, perhaps if I could summarize some stuff on innovation space, and perhaps John could do some data stuff afterwards, or digitalization. So in regards to innovation, we're always pursuing new projects. We've got an innovation strategy that comes out annually, and also something called an innovation forwards plan, which really sets our priority areas for the coming year. And so there are 5 priority areas there at the moment, including customer vulnerability, heat, electric vehicle transition, and a few others. We've just mobilising a few projects specifically regarding customer vulnerability. But having said that, for all of those that are looking to partner on projects with us out here, we've got a NIC, an innovation competition project call coming out imminently, and you can join our stakeholder list for that, where we're looking to partner with companies of all types to mobilise kind of large projects into an off-gem competition. So that's really where we're at with innovation at the moment.
Yeah, so I guess this is a bit of an opportunity for me to plug the digitalization strategy. So yeah, OpenLV has been some key work around making data data work for us and making it work for our customers. In September, we produced a digitalization strategy and a digitalization action plan, which talks in detail about our short-term and our long-term approach and roadmap for digitalization and data throughout WPD, which will drive benefits for us and our customers, whilst presuming data to be open. So yeah, it'd be really useful to get any feedback from there, and we have close links with the innovation activities from my data team to continue to drive some more innovation around data and deliver some real good value.
That's great. Again, I'm really conscious of time, and we've taken up our whole hour now, and I know we haven't got to all the questions, but as I said earlier, we will be providing the answers to them on the website. Can I just take the opportunity to thank our panelists, Sam, Chris, Dave, Tim, Aaron and John, for your input. I'm sorry some of the questions just came out of the blue, but they're there for you. I think you've caught with them admirably. And just say, I hope you can join us all next week, next Thursday, where we'll be doing the second part of this webinar, looking at how the community groups, the industrial participants and the academic participants actually engage with the data and what they did with it. So hopefully we'll hear from you here, join us next week. And for now, goodbye. Thank you.